Hello fantastic people, I hope you're doing great. Today let me start slightly differently, with a question. Have you seen the Celeste player controller? No? It turns out it is publicly available, so let me share it with you. Okay, so here it is. And let's have a look.
NANI?!
Yep, you see correctly, it has 5,400 lines of code. Yes, I know, Celeste has one of the best player controllers ever. This is probably the best platform movement I have ever experienced in my life. But technically, there has to be other way, right? There is. So let's start with the point where we all have been, right? So here I have simple player controller. At this point it doesn't have that many features, though I do have bigger version. This one has variables only for ground check, movement variables like jumping and moving velocity, and then stuff related to knockback. And this is already pretty big class. So it has at this point 121 lines of code. But now imagine that there would be double jump, the variable height jump, there would be wall slide, edge climbing and all the stuff. So this would suddenly easily become 300 lines at least, and it would have massive amount of if statements, and this would be really mess to work with. So let me show you an alternative way of doing that type of stuff. So here's my character's animator, and you may be wondering, what does it have to do with code? A lot actually. And I don't mean animating the character from code. Basically, the animator pretty nicely shows one of the concepts which we can apply or implement also in code, which is state machine. Basically, the different types of animations in our animator are different states, right? So for example, here I have the idle state, which plays the idle animation only when my character is not moving. So this is pretty important. It is not moving, there is one animation, nothing else happens unless certain criteria are met. When certain criteria, in this case, is walking condition, right? So I have a boolean value which has to be true. If this becomes true, then I'm changing from this particular state idle, it finishes off, it doesn't do anything else, just new state starts, character walk, right? And now I'm handling only walking. So my character is walking, the walking animation is played, and like the previous animation, so the idle state does not impact it at all. So it's done, I forget it was there, I do my walk and nothing else interrupts. Now imagine I would have also like animations, I don't know, jump, and yet another one, maybe fall, sorry, this one would be fall, and this one would be jump. And, you know, I would have nice criteria for all of them, I would have nice arrows, and always would have complete separation of behavior. So my character idle would never impact jump in any way. It would only be responsible for doing the idle stuff and checking if maybe there are conditions which should lead to change of state to jump. Why is that important? First of all, this separation of things will decrease the amount of code I have to work with and will centralize it in one place. So if I do put my code related to jump in a class responsible just for jump, just for the jumping state, I know that if anything is wrong with my jump, it will be there, right? If I, for example, I don't know, walk too fast, too slow, or my character doesn't stop, where it will be? In the walk, right? So this is pretty important thing from this perspective, but there is also another benefit, and that is managing the changes of state. So normally when you have a large class, like player controller, you have a lot of if statements. So if character is grounded, then it's walking, then if it's grounded, earn the jump was pressed, jump, then at certain, you know, and this number of ifs or switch statements grows and grows and grows, and suddenly you end up with a huge class which is very hard to debug. If you implement the state machine with different states, all the code is separated, so it is much easier to debug. There are no if statements. The only place where you have the if statements responsible for changing stuff is really just around the changing state. Okay, so now let's have a look at the implementation of the state machine. I will be using this diagram to help me a little bit, just so I don't get lost. This will be pretty technical, so remember please that you always can access the code. It will be in the description. If you have any questions, don't worry at all, just drop a comment under this video or join our Discord server. Link will be also in the description and probably in the first comment. So yes, now to do not talk too much, state, that's the most important object or class of all here, because that's the thing that is responsible for holding the behavior of particular state. So as you see, we'll have a specific implementations like walking state, jumping state. Obviously they will have their own variables responsible for controlling the behavior, like jump force, walking speed, and so on. And now what is interesting here is that the state extends the scriptable objects. Why is that? Basically, this will allow you to create different instances of that state. So you will be able to have 2, 3, 4 different walk states, for example, and you will be able to switch between them if needed. Specific example. Imagine that you have a character, it walks from 1 to B, obviously it has certain speed. Now, when you debug, you don't want to walk as slowly as the character normally. You want to have, for example, 4 times bigger speed, or you want to have in another state or something. You want to be invisible or something. So having different configurations will just allow you to drag and drop them without the need to remember the values, the stuff that you need to change, and so on, so on. You will have all the set of variables in one place, ready for you to use. Now let's have a look at the state implementation. The state is abstract class. That's one important thing. That's because the state itself doesn't have any logic really. Just this one, which is the storing of the parent object. We'll get to that in a second, but everything else here is abstract. That means we'll have to implement that inside the specific state. As I said, it extends the scriptable object, and it is generic, so it has to, like, the user has to provide that specific mono behavior type. So for example, our character controller. This way, if I init the state with parameter, so basically with this character controller, all the other methods will have access to it because it is stored inside a variable. Quick rundown of the methods. Init, obviously anything related to initializing the state, anything that you want to happen at the very beginning. So for example, when you jump, the first action that should happen is to push the character upwards. Capture input, self-explanatory. Update is called during the game objects update. Fixed updates the same. Change state is a method where you can place all the code related to changing stuff state from one to the other. This is quite important. This is quite nice because you have all the code related to that in one place. You don't have to search it in different places. In our example, there will be no need for the exit, but sometimes you will have to do a little bit of cleanup, or you want an action when the state is finishing. An example would be, for example, when you jump out of the water, you want a splash sound, some bubbles and stuff, and so on and so on. So that's what the exit method could be used for. Now let's have a look at the implementation of different states. Let's start with the walk state. From the very top, here I have the create asset menu attribute with the parameter menu name, state, character walk, which basically what it does, it allows me to create this particular state inside the editor. So if I go here, I click write, now I have create, and as you see at the very top I have states, character, and the jump and walk. And that allows me to create a new walk. So for example, here I have instance of this particular state with the speed 5. I can create easily another one, and as we said before, I can for example set it like debug walk, and I can give it speed 20. As easy as that. How to use it, I will show you in a second. Now I have the walk state, which extends obviously state of character controller. So that means that this state will be available only for the character controller. As you see, I have some variables related to the logic, so rigid body, ground check, character animation, which are all those two are custom classes. They don't have too much logic, so don't worry at all. Ground check just allows you to check the like does the overlap cycle, so regular checking if the character is grounded, just to have nice separation of the logic. This is pretty neat. And also the animation, the character animation is over here, and it just handles the animations, so I don't have to duplicate code. It is nice in one place. So that's here. Then I have one variable for the input in the horizontal axis, and then another one for jumping. Then I have a serialized field for speed, which allows me to set it from the inspector as we've seen before. This is pretty nice. Now inside the init, I just call the base init, so I set the parent variable as we've seen in the state. So this is happening over here. And then I check if the variable has not been yet assigned, and if not, then I basically get those needed components from different places. This is pretty nice, and why I do those ifs here is basically to do not call those methods every time I initialize the state. So obviously my character will be walking several times, not only once, so there is no sense for me to do those get component in children, get component. Basically I can do that just once because the ground check object will not change, right? This type of stuff. Now inside the capture input, I just grab the input for the horizontal axis and the input for jump button. In the update, the regular stuff, I just set the X velocity and then do stuff related to animation. Again, this is just to have nice separation of the logic. Everything is in its own nice place. In fixed update, I don't do anything because I don't have to. And then in terms of changing state, I check if my character is standing on the ground. And if so, and the player is jumping, then I'm changing the state to jump. We'll get back to the set state in a second when we talk about the state runner. And then in exit, I don't do anything. Okay, now let's have a look at the jump state, which is a little bit simpler. We start with the create asset menu to be able to create it in the editor. Two variables responsible for just providing some functionalities. So ground check, again as previously, rigid body obvious. And here I have two variables specific to the logic. So left the ground is true when the character was standing on the ground and then is in the air. And jump velocity obviously is the initial jump velocity that we can set from the inspector. Inside the init, we try to get the references to ground check and rigid body. If they are not set, set the left the ground to false, because when the jump starts, we are still standing, so we don't want to change state suddenly back to walk, right? Then we initialize the jump by pushing the character upwards. No input, because I want to have this nice feature here, that when my character walks, it can move in any direction, it can easily change the direction, but once it's in the air, it cannot change the direction. So this was pretty easy to do, because I have nice separation of these states. In update, I just check the left the ground. If the ground check does not touch the ground anymore, nothing in fixed update, and change state again. If we are in the air, so left the ground, or we were in the air and the ground check just once again feels the ground, then we change state back to walk state. In the exit we don't do any cleanup, but for example we could play nice particles when the character just hits the ground. So this is pretty nice. Now let's have a look at the state runner. So it has access to all of the states we wanted to have access to, and it is responsible for changing from one state to the other and executing their logic. In terms of code, this is pretty simple class. Let's have a look at that here. It is abstract, so again, you cannot instantiate it, you cannot drag and drop it onto the game object, even though it extends mono behavior, again because it's abstract, and it requires you to provide type, which is also extending mono behavior. You will see that in practice in a second. This is nothing challenging or nothing hard, it just allows us to pass down this type to the states, which then, as you remember, in the state init, store them as a variable. So because of that, the states can execute logic on the character without passing this down all the time or something like that. Now, what we do, we have this states list, which basically is over here. So as you see, I can drag and drop different states here. And you remember we created this debug walk. So if I place it here and start the game, now my character is walking extremely fast because too hard to control. Too hard to control, yes. But you see it moves pretty quick because we created another configuration, which I can very easily replace with the old one. Again, I don't have to set anything else manually, so this is fantastic. Now, this list in the awake method is converted to a dictionary type to state. That is a way which allows me to do not create new state every single time we go back to it. So for example, you know, we walk, jump, then we fall down and we start walking again, right? So normally what you would do, you would create new instance of that state. So you would be walking, that would be one game object, then you would jump, that would be another object, then you would fall down and start walk again, new object, and this is pretty, this adds up pretty quickly. It causes a little bit of garbage collection and so on, so it's better to avoid that. This way we can just reference the state that we already created, and there is no problem with that whatsoever. We have variable to store the active states, so the one that we execute. Now the logic. On awake, as I said, we convert the list to the dictionary. Then we set the first state to be the active state. We do it using the setState method. If the active state was already there, exits. So for example, as we said, that's the last method in the state. So for example, we create bubbles, particles, or do some cleanup and so on. And then we set new state. We get it from the dictionary, obviously, and we initialize it, and we get component of t. Again, that's what I said, that this is the way of passing down the for example, character controller to particular state, and we don't have to do anything else. Actually, this is just once and you don't have to do anything. If you see, when you see the character controller, you will be surprised how much code is there. Just drop a comment below this video. How many lines of code do you think are there in the character controller? Now, update method calls the capture input. So the input is always first, then we do the update, then we do the change state. So after the update, we check if the conditions are met to change the state, and then in the fixed update, we do fixed update. And this is really all that it is to the state runner. So it only executes the states really and just changes between them. Now I know it may seem complicated and it may seem like a lot of code, but now the state runner has to be created only once, and this is very important. You create the state runner only once and then you just extend it. You create specific states, and yes, you have to create them. That's true, but you still have to create this logic anyway, right? So this logic would be in one class. Now it will be separated to classes by behavior, which will make your life easier later on. But now if you have a look at the character controller, guys, seriously, that's it. My character controller extends the state runner. It provides itself, so its own type, to the state runner, and then just grabs extra stuff which I cannot get using the get component. So for example, this character animation, obviously it could be game object, mono behavior attached to game object, but this is not necessary because it only, as we've seen before, handles a little bit of animations. No sense to do that. Pretty easy. And seriously, this is all. Actually, if I would do the animations slightly differently, probably that would be it. Seriously, that's all you could have for some classes. So this was my rundown of the state machine pattern. We have different states. The state machine is obviously the whole mechanism. It is the state runner running different states. I hope you enjoyed it. I hope you found it useful. Have a fantastic day. Love you and bye bye.